Hello everyone, my name is Alex and I am a senior Android software engineer at Lyft. On this video we're going to deep dive in mobile system design interview, especially in mobile domain area, so it means that we keep out of scope all the story parts and focus on mobile side. The same type of interview you will have if you apply for the big tech companies or fun companies, especially for the positions that related to mobile development like Android developer, engineer or software engineer for iOS or something like this. And also in this session I will prepare some changes. So before, in my previous video, I provide some kind of real coding, a real session with drawing on the real time, but right now I prepared the slides with more structured information. So could you please share in the comments what the way is better for you to have some presentation with slides, with structured information, or more like the real interview? Yeah, please. Also, speaking about system design interview, I also need to highlight that there is no right and wrong answers. You just need to provide your opinion, your thoughts, provide a lot of trade-offs about solution A and B, say why A is better than B and so on and so forth. And also your interviewer will focus on the signals that you provide specifically for the grade that you're applying to. For example, for entry level, L3, or middle or senior position, so they will looking for the different signals. So before you apply for and go to such an interview, just check the grade system for the companies that you're applying and figure out what expectation they have for exact position, and they provide some thoughts for middle, senior, or maybe junior position as well. So let's go to the interview.
Let's design download manager or file downloader whenever we code. So as initial step, no one of interviewers will tell us what we exactly need to do. They just provide small guidance and small requirements, and everything else we need to gather by ourselves. So let's gather requirements first. The first thing we can ask is this should be a part of current application? Maybe we already developed some application and need to just have some file downloader for it, and we'll create some set of classes for it. Or maybe we need some more generic approach for general purpose library. Maybe it can be some open source solution. And our interviewer said, as far as our company have a lot of application and all of them requires to have some download manager, so we will create the download manager library and use for all our application for different use cases. So we will consider to create some general purpose library and maybe have some custom customization or configuration for specific use cases. So about the specific use cases we can talk a bit later when we discuss all the requirements as well. The next thing is, what type of the data should this file downloader download? So can it be like only image files, text files, PDFs, and maybe some kind of limitation related to this. But let's focus to create some general purpose stuff and download any binary files that we might have, like lots of files, so binary files for that question. Should we support pause, resume, and cancel functionality? Yeah, we can support it, but if we implement it, so it will increase significantly the scope of the task. So we will have to create additional things to keep track on current downloads, keep track on the status, be able to cancel, provide some feedback to the user that this download is not just only fault, it's cancelled. We can also need to have some strategy to resume it at some point from start of the file, from the place where we stop the download. So a lot of complexity, and depends on the purpose for this library, depends on the team size and the timeline for this product. We can consider do it or not. So as far as we going to cover more stuff here in this video, let's also think about resume and pause functionality for such download manager. The next thing should be show actually somewhere the download process and progress of the download, maybe return to the clients, the user of our library, something like this. So let's keep it out of the scope, but discuss how I can do so at the end of this interview. Should we download the files to the memory or to the disk? So I believe it's general purpose library. We can consider about two options: memory and disk. It's memory more for the caching stuff, and disk like general purpose. Why we need to download those files to keep them and use it in the future. But right now, let's keep our scope small and think about only to download files to the disk, like to the persistent storage. Maybe there is some files limitations. Should we download more that size or another size? So we can consider it, but as far as we create some generic purpose library, so we can also add some configuration to design it, but basically no limitation for the file size, depends on what is set in the configuration. Should we support multiple downloads in the parallel? So it's really a tricky question, so it will produce a lot of complexity for sure if we will just download one file at a time, or we should support multiple downloads. Yeah, so but as far as this more generic library, we can consider to create one download at a time as MVP, or we either can and deliver multiple downloads in the future for the next phase. If we limited time, if we not limited time, and we have a lot of engineers that will work on it, we can parallel our work. We can also discuss in this session about the team structure and how I can assign different engineers to deliver this work as well. So, but let's think that we have multiple downloads. Amount of such downloads we also put in some configuration initially, but we can also consider some energy safety cases and discuss it in the future about limitation of downloads. Depends on the battery, depends on the type of the network. It's a cell phone or a cell network, or maybe it's a Wi-Fi, and so on and so forth. So, but think about the configuration right now. The next thing, should we support priorities for the task? For example, if some downloads more critical than another, we can have a lot of cases for it. So, and yes, we should support, but if we're going to support prioritization, it also means that we add more complexity to a queue of our task, especially we're going to implement to parallel downloads. Yeah, but yeah, let's think how we can implement it. Yeah, let's do so. And can we download some files in the background? It's also additional complexity for our task. We can also consider to skip it for initial version. Depends on the purpose of this library. But for now, let's think how can implement it in the background. Don't think about the platform iOS and Android, but generally how it should work. Should we support partial downloads? It's HTTP ranges, like standard thing. So let's keep it out of scope. But yeah, for sure, let's Google it. Maybe it will be useful for your interview, especially for download manager, maybe upload manager. So let's also consider it to discuss. And what else? What else you can discuss depends on your seniority level. It's about your scalability or your usability or your library. If it's open source, how we can support those open source library, having internal resources, external resources, maybe some process to collaboration between people, and so on and so forth. Also speak about the scope and the future of this library, the next steps, and how we can reuse this library in the future. Okay, so what we gather actually. some functional requirements. We're going to implement some standalone or general purpose library with some custom configuration that our users of our library, some end developers, will apply to this library to configure amount of parallel downloads, maybe size of the files, maximum size of the files, or something like this. This library should be capable to download multiple files concurrently in a parallel over the HTTP and save them to persistent storage on the disk. We also consider that we will support pausing and resuming functionality along with the cancels of some downloads, which is really important stuff. And this library should show, but maybe not exactly to show, at least to return some list of active downloads and at least to keep track of what is currently downloaded right now. So yeah. And non-functional requirement for this project is the number of simultaneously downloads in parallel downloads. We can set them in our configuration, and also it can depend on energy save strategies that we can discuss later. There is no limit on the files to download, but we can consider to just avoid some edge cases and errors. We will allocate enough space in our persistent storage when we just start to download some files, and then replace some empty or 0 bits of this file with the information or the data, binary data that we download from the network. But we still can have some configuration to limit the maximum size of each file for sure. And partial download are not supported currently. It's about HTTP ranges. We discussed that we keep it out of scope right now, but we can also consider to deliver it to the next phase and the next milestones of our project. So at first, let's design and create some high-level diagram how our library should work, should look like, what the main components of this library we will have. So yeah, so the public class for this library, it will be called file downloader. It's the files that our users or developers in our case will see, and yeah, it's like public interface. This file downloader will receive some download requests to download some files, and as a result it will provide result. So it depends on the platform, on your application, it can be different. So maybe you can have reactive approach and return some result reactively, or have some callbacks for success, failure cases, so on and so forth. The next thing that we need to have here in our library is to receive some configuration for the downloader to support multiple edge cases, to support multiple use cases, and then we will create a download manager. Download manager, it's a thing that will operate with a list of downloads that it will receive from the file downloader. It's more or less like a public class that's not visible for the end user. So download manager will create some journal of the downloads and create some queue downloads, store this in the database, also keep track on the priority, maybe some progress, and so on and so forth. And then download manager will send some action to worker or download service, and download service itself will go to remote repository, and remote repository will go to API or network or server or data storage whenever, so somewhere in the cloud. And the result of this download from the network will store using a storage repository for persistent storage. In our case, we'll store in some files on the disk storage. We do need such repository like a storage repository and remote repository in case we will have some different implementation for API, for storage. We can change them quickly in the future to make our architecture more scalable, to have some another level of abstraction. And also between all these layers, we will provide some detail objects, some data that also related to a particular level. So there is no sense to provide from the start to the end the same data, the same object as a result. So we'll modify, provide, and everything will be encapsulated and isolated from each other. It will provide more scalable solutions, so we can also use dependency injection for it, and yeah, a lot of good things that we can apply here. So, but let's discuss about exactly download manager. So what it is. So download manager will operate with task. Task means it's like type of the work, job. So the task will contain the URL where we should use to download something, some destination of such a file on the persistent storage. So if it's configured, for example, during a download request, so we can keep it here, or if it's not, we can create some temporary name, for example, in temporary storage as well. Yeah, and it also has some priority and so on and so forth. This task will go to the queue for our journal repository, and this queue will be operating with priorities, the time when this task was added, and so on and so forth. So we can apply different strategies here and change them, maybe add them to configuration, and so on and so forth. Then when queue on the top of the list and it's ready to execute, and we ask our workers, maybe some worker manager, do we have some empty workers that is ready to do so, and provide these tasks to the workers. Amount of workers is the same like amount of parallel downloads that we can allow to our library. So for example, in that case, we allow just only 3 parallel downloads, and if there is no empty or workers, so the task will wait, and when some worker will finish download it for the failure or success case, it will go to another task, so the next task from the queue. And the worker itself will operate with, as we said before, with remote repository to download some data from the network, and some storage repository or persistent storage repository to put it somewhere in the persistent storage, in our case to the disk. So let's think about the public APIs that the developers will see and will use for our library. So the file downloader is the main class of our application, so it will have a couple of methods, so init method, or maybe it will be like part of constructor whenever. But yeah, let's keep it in init, or maybe create some builder as well. So it will have some configuration and receive some configuration. The next method that we need to have is download, which will receive download request and provide as a result download task that will have some information about the progress on this task, for example, and ability to cancel or pause this particular task. So we'll have a list of active downloads, as we discussed before, and the ability to pause, resume, and cancel all the tasks that we currently have and currently executed. Download request will contain a couple of things. It's URL that we use to where we need to download those files. Destinations, it's where in the persistent storage we need to store it. Can be optional stuff, so we can create the name of these files automatically for different reasons, for different scenarios. And we also can set priorities, so it's critical task or not so critical. Yeah. And also this file downloader will receive some configurations. We said before it will contain maybe some amount of maximum parallel downloads at time. maybe some download size for each file. For example, do not allow to download files more than 2 megabytes or some queries. And as a result, for example, download method and the list of active downloads will provide us download task, and download task will have a couple of methods to cancel, resume, and pause this task for sure, but it also will provide some information about this task. It can be different, depends on your application, depends on the platform. So you can observe something updates using coroutines for Android, and maybe some promises for iOS. So, or either you can add callbacks for success and failure cases. So whenever you choose, depends on your platform. So the download process for this library. So how it should looks like. So we start the download from the worker. We start download inside the worker. Then we download some portion of the file, not all of this, because it will be more flexible solution. We have download just only a range of these files, some amount of bytes, and then if everything is downloaded, we send event to everything is finished, or if we have some issue during the downloads, so we send the final event as a failure. Also, when we download each part, we can consider to pause or resume it. So we just pause downloading, not the whole file, and we will be able to start from the last chunk of these files that we stop to download, and this will allow us to not check should we status of this should we pause it or resume on any bytes. So we download the part, download the chunk, check destiny of this task should be paused or not, and then continue or pause or cancel. So yeah, what we actually need to do for the start case, we will create some empty files in persistent storage, but this file will allocate the space that we need for this file eventually, and we'll fill up this file with some null bytes or whenever information we have just empty, 0 bytes or something like this. And then we download this file part by part and add downloaded part and replace the files, the bytes from the files with download parts. Yeah, again, part by part till we finish all of it. And as a result, we will report the task is successfully finished, or we have some errors, failure for different cases. Maybe it was cancelled, or maybe it has some network issues, and so on and so forth. At the end of the interview, your interviewer can ask you the follow-up questions, or you wanted to tell your interviewer something that you didn't cover before. So one of them can be some battery or electric efficiency for your application or for your library in our case. So for example, it's all related to simultaneously downloads and how many parallel downloads this library can have. So it can depend on the amount of CPUs that you have on the device, or maybe from the network type, like for the Wi-Fi we have 16, for the cell phone we have just only 2 or maybe 1. And step back on the battery. So for example, if you almost run out of battery, you have like only 20% of your battery on the device, you can reduce the parallel downloads up to 1 and keep it safe. Also thinking about the battery safe policies on the device. For such a case, some background downloads, maybe you can pause background downloads if you're almost run out of battery, something like this. So, and also speaking about the background and notifications, so we can provide some notifications in the future. For example, for Android, create some foreground service that will show some notification with downloads, some information about some downloads, maybe some progress and so on and so forth. Maybe deliver to the next step, have some configuration for it. Also thinking about how we can organize the background downloading. Maybe it can be in different process, and it will have different life cycle, depends on iOS and Android, so it will survive when up in background, or maybe the whole device will be reloaded and rebooted. And the next thing is that how we can report the download progress. So, for example, our download manager, download worker, eventually will download another chunk of this file, and it should report back to some results about this download. It can be like a percent of download for such a file, but it's better to return the amount of bytes that download and the full size of this file, so it will be more flexible solution. Also, we can keep track how many bytes was downloaded in our database, in our journal, because we can cancel these download managers and resume it. So we have some information, persistent storage in database about how much chunks or how much bytes actually we download from the network, and we continue to download after it if our application or library, in our case, did not survive something that happened with our device. Yeah. And thank you everyone for watching this video. If you find this video useful, just subscribe on my channel and I will provide more usable stuff for you. Thank you.